Oh, you're there. Page 5 of 20.
Yeah.
All right. We have already looked at this table, which
Yeah.
contains the first few elements in the periodic table, and from there we could identify the periods. How do you know the period again?
What do you mean?
For instance, for aluminium, this is aluminium.
Yeah.
What's the period that aluminium belongs to?
Do you mean the group?
Yeah, I mean period. Okay, first of all, if you want us to talk about group, I can talk about group now. So what's the group for aluminium? What's its group? What group does it belong to?
3.
It belongs to group 3. That's aluminium here. It belongs to group 3 because the outermost electron is 3, what we call valence electron, right?
Yeah.
Now, what period does it belong to?
3.
Why does it belong to period 3?
It's because
it has 3 shells.
Yeah.
It has 3 shells. Okay, let me just zoom it up. Let me zoom it in a bit to accommodate what I need to talk about. So this is 8. The electronic configuration of aluminum is 283, isn't it?
Yeah.
To show that the first shell takes 2. You know, the first shell takes a maximum of 2 electrons. The second shell a maximum of 8, the next a maximum of 8, and so on, right?
Yeah.
Okay, so that we don't waste time, if I had included another element, do I have any space here? Let me call it calcium, for instance. Calcium, the atomic number of calcium is 20. Calcium is 20, which means it has 20 electrons.
Yeah.
Because atomic
But
number...
There'll be 2 in the first shell, 8 in the second, 8 in the second.
So we have 2, 8, 8.
4.
Are you sure? Can you verify?
6.
Check again.
Wait. 8, 16. Oh, there'll be 2.
So 2882, right?
Yeah.
All right.
So it'll be in group 2.
It will be in group what?
2.
It's in group 2. And
Yeah.
period what?
Period 4.
Period 4. All right. These valence electrons, or these outermost electrons, which we call valence electrons, will determine its oxidation state. For instance, what's the oxidation state of, let's start with this one, sodium, which is 281. Oxidation number, what's the oxidation number? Like the ion it will carry. +1, because it will lose this.
Yeah.
When it loses electrons, it becomes positively charged.
Yeah.
What about magnesium?
It'll be +2.
+2, okay. What about phosphorus? -3, okay, because it will need 3 more electrons to complete its shell to make it 8. So it will collect 3 electrons. It gains 3, which is positive. When it gains electron, it becomes negative.
Yeah.
All right, we said all that last time, that when it gains electron, it becomes negatively charged. When it loses electron, it becomes positively charged. Okay,
Yeah.
and I told you that when a metallic ion bonds with a non-metallic ion, like when positive combines with a negative, it forms what you call ionic compound, right?
Yeah.
An example is this one.
That one there, yeah.
Yeah, this one, aluminum oxide. Okay, let's even look at aluminum and sodium. What would be the formula of aluminum and sodium when they combine?
Is it Al3Na?
Oh, sorry, it can't be aluminum and sodium. Both of them are metals. I made a mistake. They don't combine like that. It's usually a metallic ion and a non-metallic ion. So we can look at maybe aluminum and which other non-metal do we have here? And chlorine. Aluminum and chlorine. Let's see. By the way, let me write what chlorine is. Do I have chlorine here? Chlorine is 287. 287. So what's the ion of chlorine?
-1.
So it will be Cl minus 1. 1 minus if you like. So if aluminum combines with chlorine, so what will it form?
It'll be
AlCl 3. You know the swap valencies.
Yeah.
The swap valencies. Aluminium is 3 plus, chlorine is 1 minus. So the 3 comes to chlorine, right? The 3 of aluminium goes to chlorine. The 1 of chlorine comes to aluminium, right? Okay, but you don't need to write the 1. You just write AlCl3. Okay, that's actually how we got this. Just a quick review. That's how we got aluminum oxide.
Yeah.
You know, oxygen is 2 minus. Oxygen is 2 minus and aluminum is 3 plus. So for aluminum oxide, the 3 goes to oxygen while the 2 comes to aluminum. We always write the metallic one before the non-metallic one. All right. Let's take this further. Some compounds have multiple valencies. In other words, before I talk about the compounds that have multiple valencies, let's talk about compound valencies. Compound valencies. Go to page 7 of 20.
Okay.
7 of 20. So they are usually together, and then they have they carry a single valency for the entire thing, like OH. Are you listening to me?
Yeah.
OH as
Isn't that like where something mixes with like an alkali or something?
yeah, we get to that, but I just want to tell you that there are some compounds that carry a single valency. Of course, usually when you have an OH is an alkaline or a base, but I'm looking at it generally as compound valencies. For instance, OH, which is called hydroxide, it carries a valency of 1 minus. CO3, which is called carbonate, carries a valency of 2 minus.
Okay.
And of course, NH4, which is called ammonium, carries a valency of 1 plus. NO3 is called what?
Nitrate.
Nitrate. It carries a valency of what?
1 minus.
SO4 is called what?
Sulfate.
And it carries a valency of 2 minus.
2 minus.
This one is called dichromate, if you like 2 chrome. You know, anytime you hear of ATE, let me also give you an idea. Whenever you have ATE, it tells you that something must be there. What's that element?
Is that oxygen?
Oxygen, yes. In fact, if you check, ATE means there must be an oxygen there.
Yeah.
Now, if it is only IDE means there are only 2 elements involved. For instance, calcium chloride. Let me just write it. Calcium chloride. Did you see what I wrote?
Oh, chlorine.
So talking about only calcium and chlorine. So IDE means only two elements are involved, okay? IDE means only two elements are involved. But if you have ATE, there might be three elements, but oxygen is one of them. So IDE is usually only two elements that are involved. Okay, but we'll come back to that because I was trying to explain something else. Okay, so these things they have a single valency for the entire thing. So O and H together carries a valency of 1 minus. NO3 together carries a valency of 1 minus, for instance, and so on. SO4 together carries a valency of 2 minus. So
but
now
you know how it says 1 minus 1 plus. Do you only just write it as a minus and a positive? You don't really write the 1, do you?
yes, for 1 minus you don't need the 1. I just needed to emphasize that you could just say plus. Just like if you wanted to write X, you could say X or 1X. It doesn't. Even if you wrote 1 minus, it will be understood that it's just minus.
Yeah.
You could write X or 1X is understood, but it's preferable to just write X. Anybody who is looking at it will understand what you mean. Alright, so a very quick one, because we're going to have a series of lessons today. Really, it's a long haul. For instance, let me give you an example here. For example, aluminium combining with carbonate.
Yeah.
What's the valence of aluminium?
3 plus.
And carbonate is?
2 minus.
So they also swap valences. And so you're going to have what? Aluminium carries what?
Yeah. Al2, so it carries the carbon dioxide thingy. And then it will be CO3, because they swap.
They swap. So the CO3 as a carbonate, we collect the valency of aluminium. So CO3 we have a 3, while Al we have the 2. Right?
You know when you're calculating like the relative formula mass or something, and you know how there's that 3 here, but then there's also that 3 there. What do you do with that?
Okay, so first of all, you calculate. For instance, carbon is 12, oxygen is 16. For instance, you would have done 12 plus 16 times 3. 16. There are 3 atoms of oxygen.
Yeah.
So that would be 16 times 3, isn't it?
Yeah.
Plus carbon, which is 12. Now, 16 times 3 is, I think, 48.
Yeah.
Yes. So 48, is it 48? 16 times 3. Let me just do a simple mathematics. 16 times 3. It's 3 times 6 is 18. It's actually 48.
Yeah.
So 16 times 3 is 48. That is for the oxygen. Why did I say 16? 16 is the atomic mass of oxygen.
Oxygen, yeah.
So mass, all of those things are provided in your periodic table, which you always have before the exam. So 16 times 3 is 48, plus carbon, which is 12. So 48 plus 12 gives you 60, right?
Yeah.
Then the 60, you will multiply the 60 by 3.
Oh.
That will now be 1.
So you don't multiply this by 3, you just do it by 2.
You only multiply Al by 2 because Al is 2. I think Al is 23 or something.
Oh, okay.
So 23 times 2 plus all of those ones we calculated, and then when you add up everything, you get the molecular mass.
Yeah, because you know what I thought, how in algebra you time this by this.
You could actually do that. You could actually say 3 times 3, 9. 3 times 1, carbon is 1 here. You can actually open the bracket and have C109, and then you still get the same answer.
Oh.
Yeah, you can. You really can. Or you find CO3 first, and then multiply what you have by 3. You will get the same answer. Whichever way you go about it, you get the same answer. Alright, so that's that about that. Now, can you quickly do this so that we don't waste time on this? For instance, what's the formula of aluminum oxide? Let's just practice this.
Oh, aluminum oxide.
Write down the formulas of these compounds. Okay, before we do that, I needed to talk about this. I have mentioned compound valencies. That's actually what we call it. Some people call it radicals, compound valencies. That's
Yeah.
two elements or three elements together that have a common valency, common oxidation number.
Yeah.
So it's also called radicals because usually when they go into a reaction, they come out the same as if they are it's the same units, as if they are inseparable. They usually do that. They
Wait,
can,
but you know the aluminium oxide? Obviously, aluminium is Al3 plus, but then the oxide is that OH minus, or is it just H minus?
what do you mean? Aluminum oxide? You mean?
Yeah,
Aluminium is what's the valency of aluminium?
3 plus.
Okay, what's the valency of oxygen?
Oxygen is
Aluminium
2
is
minus.
Aluminum is 3 plus, oxygen is 2 minus. So
Yeah.
they will swap valencies, so it will become what?
Oh, okay, yeah. Okay. Oh, it'll just be Al2O3.
So it will be Al2O3.
No, because I just thought because it says oxide, it'll be.
You know, like I told you, IDE, whenever you have IDE, it means there are two elements involved, and these two elements are aluminum and oxygen.
Oh, okay.
By the time you'll be hearing something ATE, like this carbonate, you will
Yeah.
notice that there will be three elements involved. We do that. All right, let's go to lithium oxide.
Lithium oxide.
Lithium, if you check your periodic table, lithium has a valency of 1 plus because lithium is in group 1.
Yeah.
So let me be using a blue pen to write their valencies and then this to write their answers. Aluminum is
So that will just be Li2 and then O.
so okay, you said it would be Li.
And then just O.
Li. Oxygen is 2 minus, remember?
Yes, Li2.
Okay, Li2, then O. Okay. Alright, so let me write the O properly. Sorry, I think I need to do this properly. Li2,
And then O. Just
then O. Alright, yes. There are some elements that have multiple valencies. I need to talk about that. For instance, look at copper. You see this copper here? It can have a valency of 1 or even 2. So multiple valencies.
Okay.
Iron can have a valency of 3 or 2. You can have carbon with a valency of 4 or 2. So they have multiple valencies.
Yeah.
Depending on the element they've combined with. They can have multiple valencies. For instance, iron 3 oxide, the number in the bracket tells you its oxidation state. So iron 3 oxide, the valency is 3 plus, okay?
Yeah.
The valency is 3 plus. I know you already know that oxygen is 2 minus, isn't it?
Yeah.
So what would be the formula of iron 3 oxide?
It'd be I. Wait, what's the?
Iron is Fe.
Oh, okay. Fe2 and O3.
Fe2O3. All right, let's move on to something more. Let's look at ammonium sulfate. This J, so that we don't waste time.
Ammonium is 1 plus.
Ammonium is 1 plus.
Sulfate is 2 minus.
Sulfate is 2 minus.
There'll be. It'll be NO.
What's the
No, NH. Well, NH2.
NH? Actually, ammonium is ammonium itself is NH4.
Oh.
Check it up here now. Is it not?
Yes, it's NH4, but then.
The entire ammonium is NH4.
Oh, okay.
The entire ammonium is NH4. So we're going to have NH4 for the entire ammonium.
Yeah.
So what do we do?
Would it be? Would you put a bracket?
Yes, you put a bracket. Good. So it's going to take the 2 from sulfate, isn't it?
Yeah.
And then what do we put? Continue. Go ahead.
And the sulfate is SO4. Put that in a bracket, and that would be. Oh, that would just be SO4.
SO4, because you don't have to put it in a bracket because 1 is what will be outside of it, isn't it?
Yeah.
Once you have 1 outside of it, you don't need to put it in a bracket. So you don't have to write SO4 1 minus. All right, let me see if there's something that you can do here before we move on to something else. Okay. Can you do aluminum dichromate? Let me go to the next page and write it. Aluminum dichromate. Please solve it.
Okay, that would be aluminium. Oh, aluminium. What's dichromate?
You need to write. I hope you have your pen tablet.
Yeah, yeah. Oh. Okay, hold on. I'm just thinking first.
Yeah, when you're done, you can write it down here. I'm going to give you the magnesium sulfate. You can do for magnesium sulfate.
You know the valency for aluminium is 3+, isn't it?
Yeah, 3 plus.
Okay, so this one would be bracket. You know for the dichromate, is that CR207?
Yes, the entire thing. The entire thing. Are you putting a plus in between?
No, that's not meant to be a plus. That's just meant to be a. Can you delete? Let me do that.
Your pen is kind of giving you issues.
Small.
Yeah, maybe the internet.
Magnesium sulfate, it would be.
Okay, so what you wrote here is Al3. Let me just make it better. Al3. Al2 rather.
Yeah. And sulfate is SO. Is magnesium 3+?
Magnesium is in group 2.
Oh.
You know, you have your periodic table, so you can easily tell their valencies from their groups.
Yeah.
Magnesium is in group 2, so magnesium is 2 plus.
Yeah. Okay.
Are you sure you will leave it like this? Whenever you have it this way, you need to reduce to the lowest term.
Wait, what?
You will need to reduce it to the lowest term.
So would it just be?
Yeah.
You cancel them out?
Oh yeah.
Oh.
Yeah.
So just be like MgSO4.
Good. So it just be MgSO4. Oh,
minutes.
okay. Yeah, I will do that. All right, let me give you this one before I do that. This is carbon. Right, for carbon 4 oxide.
Okay, carbon.
Carbon is in group 4.
So it'll be 4 minus, 4
4,
plus.
4 plus, yes.
Oxygen is. Oxygen is.
Aluminum is 3 plus. Dichromate is 2 minus.
Oxygen
Magnesium
is
is
2
2
minus.
plus. Sulfate is 2 minus. Carbon is 4 plus. Oxide is 2 minus. Oxygen is 2 minus, rather.
Okay. Is that right?
You've forgotten, though you asked me to make a note of it. You reduce to the lowest term.
What, even with this one?
Yep.
Why though?
Yeah, you can always reduce to the lowest term. Once you find something that can cross out. Assuming this was 6 and this was 2, you could have reduced the lowest term.
Oh, is it like
If you can reduce those.
is it CO2 then?
Yep, that's CO2.
Oh, so you basically kind of it's like lowest common.
Exactly.
Yeah, it's like maths basically.
Exactly. So, what do we call CO2, by the way?
Carbon dioxide.
By the way, yeah, carbon dioxide is actually carbon 4 oxide. You know.
Oh,
Okay.
but if you don't simplify it, do you still get the mark?
No, you won't. You have to simplify it.
Oh, okay. I need to make sure I remember that.
So I'm writing down the notes.
Yeah.
So you simplify to get that. All right. Yes. Can you go to the previous page?
Yeah.
All of these compounds you have from a metallic ion with a non-metallic ion
Yeah.
is what we call ionic compounds. Ionic compound, you remember?
Yeah. But what happens if there's a big number in front of the element?
Like, give me an example. You usually find those huge numbers in.
Like, okay, let's say it was 2 mg plus O2. What would you do with that?
Oh, okay, that is a different case. What you're talking about? Let me go back to that. Where you that's what you have when you are balancing it. You're balancing the chemical equation. We talk about that.
Oh,
We talk about that. For instance, if you had CO plus O2 to give
yeah.
CO2, you know, or C plus O2 to give CO2.
Yeah.
Now you balance. Balancing is a different thing. It's when we are balancing it that we put numbers in front of the element or compound. These numbers are added in front. That's added before the element. Those numbers are the moles or the number of molecules.
Oh.
These ones you have as subscripts. These ones you have as subscripts gives you. These ones give you the number of atoms. Do you understand?
Yeah.
In
Yeah.
fact, talking about that, how many atoms do you have here for CO2? How many atoms?
2.
No,
No, you have what? No, you have 1, but
what
there's 2 oxygens.
you have one carbon atom and 2 oxygen atoms. Altogether, how many atoms?
Oh, 3. Yeah.
3 atoms. How many elements?
2.
2 elements. Okay, so that's different. So let's even look at that. How many atoms do you have in this MgSO4?
There is 6.
6, yes. 4
Yeah.
oxygen atoms, 1 sulfur, and 1 magnesium. So altogether 6 atoms.
Yeah.
Can you calculate the number of atoms we have here?
There's 14.
Let's see.
No.
It's actually huge.
Yeah, wait.
Because oxygen alone is how many?
21.
21. 7 times 3, 21. Plus
Yeah,
chromine, which is 6. That's 2 times 3. That's already 26, right? 21, 27. That's already 27.
29.
That's 26 plus 20, 21 plus 6. That's 27. Then plus 2.
29.
29 atoms. Okay, so but if we have this, if we have, okay, I want to write out one formula that we can balance, but I think we do that in the next slide, because balancing is a different thing. So but all I'm trying to say is, if you have a number in front, that's before it is giving you the number of moles, you will see that. Don't worry, we're going to it, so don't worry, we get there. But the ones as subscript give the number of atoms. Okay, I hope that's clear.
Yeah.
All right.